Okay, so the entire cerebral cortex, again, cerebral cortex, gray matter in the cerebrum, is organized into multiple sensory areas, association areas, and motor areas. There's, for example, for sight, there is an area that only receives the light waves, the visual information. There is another area, association area linked to this one. There is a visual association area. That's the one that gives meaning to the images you are receiving from your eyes. And then there is other multiple association areas through this that connects all of these groups using the association fibers. Now, there's, as promised, I'm just going to cover in this class, in this course, two areas that are important for us to understand how is this information ingoing and outgoing from the cerebral cortex, and how is the direction of the at least the general sensory and general motor information in here. These two unique areas, as I introduced you in the previous video, is this gyrus located, okay, this green line right in here, that is the central sulcus, right? We just described that, the central sulcus, and that is dividing the frontal lobe from the parietal lobe. Now, there is a gyrus, and remember, a gyrus is just one of those ridges or elevations in the surface of the cerebrum. So there is one of them located right in front of the central gyrus and the frontal lobe, and there is another one located behind it, right posterior to the central sulcus and the parietal lobe, two different lands. So the purple one is called, since it's located right in front of the central sulcus, we are going to call this one because it's located in front, pre-central, in front of the central sulcus, and it's a gyrus, pre-central gyrus. This is the anatomical name. And the pink one, how do you think we're going to call it? Post-central, central gyrus. Another anatomical name. Functionally, in the precentral gyrus are located all the motor neurons that initiate a motor command. And in the in the postcentral gyrus are located all the somatosensory neurons. Remember the functions of the parietal lobe? That it deals with somatic sensory information, all the sensory information from somatic receptors gets in here. So how did this go? Let's say, do you remember the fly that was bothering me the other day in the other chapter, my example? So you have your mosquito here and it's buzzing, meaning buzzing, and you can hear that and you can listen to that, and that's an ear, you know that is an ear, right? And you can hear that, and that's an eye, and you can feel it. So all of these sensations, somatosensory sensations, vision, hearing, and tactile informations arrived right here on the neurons. I mean, they are detected by the receptors, right? The receptors send it to the sensory neuron, okay? And the sensory neuron relays that information right here in the somatosensory cortex. All the sensory, general somatic sensory information. Conveniently located right in front of that is the primary motor cortex. So when this information is integrated, the primary motor cortex is the one sending out a motor command. So if it's relevant or bothering to our cerebral cortex, we are going to swap this mosquito or this fly out. And that the contraction of the muscles of the arm to swap that fly is that order for contraction comes from the primary motor cortex. So in general, and this applies also to the spinal cord that we'll describe later, all the sensory information arrives from the posterior aspect of the central nervous system, and all the anterior motor commands come out from the anterior aspect of the central nervous system. So posterior, incoming, anterior motor commands are coming out. Now, this part is very cool. The primary motor cortex and the somatosensory cortex are mapped. And this happened like, I don't know, hundreds of years ago by a guy named Brodmann. And he could map out, imagine how rude and cruel was that, and barbaric, but he did it. And still 2000 and after 2000, I'm not gonna say the year, we are still using these maps in neurology, in neurosciences. So in here in orange, we can see this is front, this is posterior, this is the frontal lobe. The most posterior gyrus of the frontal lobe is the precentral sulcus, and the most anterior gyrus of the parietal lobe is the the postcentral gyrus containing the primary somatosensory area. So, in the primary motor cortex of the precentral gyrus of the frontal lobe of the cerebrum, here this is the map. So you can see big parts of or parts of our body that are, appear bigger than others. So, for example, our lips, our tongue, the hand are maybe the biggest, and the face in general, the biggest face or the biggest part on this diagram. And that means that a lot of neurons in this primary motor cortex are dedicated for these areas of the body. So there's more neurons controlling movements of the tongue, of the facial expression, and of your precise movements of your hands than movements of your arms and legs, for example. In the other end of the spectrum, we have in blue the postcentral gyrus, showing you the primary somatosensory cortex. And the same thing in here. Look at the tongue, the face, and the hand is generally bigger than other areas on the body. This means that these areas are more sensitive, receive more sensory or have a greater concentration of sensory fibers or receptors in there, and they're more delicate to touch. It's totally different, the touch that you can feel in your any part of your skin, the one that you can feel in your leg or in your back. So this means that, for example, the primary somatosensory cortex receives the sensations that if I have, for example, a mosquito right here biting me into my cheek, that information will arrive precisely to this area in the in the somatosensory cortex, right here in the postcentral gyrus of the parietal lobe. Now, important to understand in here is that this information crosses to the other side. So the mosquito bite that I'm feeling in my right cheek is going to be delivered to my left somatosensory cortex in the left parietal lobe. Now, in the other way, I can pinpoint maybe having a patient awake during a brain surgery, of course, under anesthesia so he can feel no pain, and I can stimulate this area, precisely this area of the primary motor cortex, and I will see the patient and it will contract one of his facial muscles. That precise these movements are, or this map is. So remember how big the areas of these of the body parts are in here are translated in the amount of fibers that area receives. So on the primary somatosensory cortex, the head or the face, the hands and the tongue are bigger, meaning that they are more sensitive, they're more delicate parts of the skin than others. And in the motor, the primary motor cortex, the bigger areas are the ones that receive more motor fibers, meaning that with those areas we can perform more skilled and delicate, precise movements. So maybe when you see yourself in the mirror, you see like yourself, like you are, but you look like this. This is the bigger areas in these pictures. This is, by the way, the motor and sensory homunculus. That's the name of these guys, representing the how important for the cerebral cortex each part of our body is. The bigger parts are more important than the smaller parts. The bigger parts receive more motor and sensory innervation than the others. Motor receive more motor fibers, so movements are more precise. And sensory, well, these areas are more sensitive, or more uh, uh, innervated, okay, than other areas. See you in the next video.